My topic VSPER theory present by Dudala Lavanya, BSc, MPC. Here I am discussing about the valence shell electron pair repulsion theory. Here given that planar, triangular, tetrahedral, trigonal, pyramidal, bent. That molecular shape. VSPER theory assumes that a shape of a molecule is determined by the repulsion of electron pairs. The diagram, how the repulsion and attraction be occurred, and the covalent bond for H2. H2O is an example of water molecule. It has the 104.5 degrees bond angle. Electron dot Lewis structure. Theory predicts shape of compounds, abbreviated VSPER. VSPER pronounced VSPER stands for valence shell electron pair repulsion. VSPER predicts shape based on electron pairs repelling in bonds or by themselves. Electrons around central nucleus each other, so structures maximally spread out. Each shape has a name. You will have to know this already. Name of the shapes here given: tetrahedral, trigonal pyramidal, bent, linear, trigonal planar. How the models are designed here: tetrahedral, trigonal planar, bent or V, trigonal pyramidal, linear. Example as a methane CH4. Its model is tetrahedral and the bond angle is 101.5 degrees. Bonds are all evenly spaced electrons. Its shape is trigonal pyramidal. Less repulsion between the bonding pairs of electrons. The ammonia and H2CO, it is bent or V. Two unshared pairs of electrons at top of O repel bonds and force them to bend. The molecular geometry of H2CO, and again given the molecular geometry of H2CO. Shape and orbitals. Tetrahedral is sp3 orbital, planar in sp2 orbital, linear is sp orbitals. Simple hydrocarbon shape is not planar but tetrahedral. Here given the diagram of CH4, methane. Roth bond contain the methane gas. Molecule, Lewis structure, number of electron pairs, shape. Suppose CH4, it contains the Lewis structure, 104 bond angle, 4 tetrahedral, electron pairs is 4, tetrahedral shape. It contains the 104 bond angle, 3 shared electrons, 1 lone pair of electrons, trigonal pyramidal shape. Is the uneven distribution of charge. One side of molecule is negative, one side is slightly positive, creating poles. Non-polar molecules. No difference in charge on outside of molecule. Electrons are evenly distributed, uniform charge on outside of molecule. Here we will take step 1. Determine polarity of bonds. Which atom attracts electron more? Step 2. Determine polarity of molecule. Shape is linear. If bonds making up a molecule are polar, then the molecule may be polar or non-polar depending on its shape. Charges in located on the carbon atom. The center of the negative charge is also located on the carbon atom. Since center of both the positive and negative charges are located in the same spot in the molecule, there is no difference in overall charge, so the molecule is non-polar. For dioxide, step 1. Determine polarity of bonds. Which atom attracts more? Center of positive charge is on the sulfur atom, while the center of negative charge is located halfway between the two oxygen atoms. Since polarity of the bonds and shape of the molecule results in an uneven distribution of charge, SO2 is a non-polar water molecule. Polarity of bonds based on electronegativity difference between hydrogen and oxygen, bond is polar. Shape of molecule based on VSPER theory, water is bent. Center of positive charge is between two hydrogen and center of negative charge on oxygen. Water is a polar molecule. When the CH3Cl chloromethane, polarity of bond C, carbon hydrogen bonds are non-polar. Carbon chloral bond is polar. Shape of the molecule based on VSPER theory. Chloromethane is tetrahedral. Chlorine end of bond is negative, while carbon end of bond is positive. There is a net separation of charge, so molecule is polar. This opportunity for chemistry department.